Alright, so in this video, we're going to be simplifying the expression the cube root of 4 times the quantity negative 3 to the fourth times 2 to the fourth. Okay, we're going to use the exact same tricks that we've used so far in all the other examples, but the only thing that we need to really worry about here is how to handle this negative 3 to the fourth. To some that might be obvious, but to those who it's not obvious for, we'll explain that in full detail as we proceed through the example. So, looking at what we have here, we have a product of things being multiplied on the inside of this radical here. So what do we want to use? We want to use the product rule for radicals to simplify this a little bit first. So I have 4 times negative 3 to the fourth times 2 to the fourth. So let's break this thing up. By the way, there are several ways of going about this, but I'm going to do one particular way, and it'll all come out to be the same thing anyway. So we have cube root of 4 times cube root of minus 3. It's very important that you keep the parentheses here. And then you have times the cube root of 2 to the fourth. All right, so now let's see if we can break these things up as much as possible. Okay, some of these problems are very much trial and error, so we'll just see what happens when we break things up this way. As before, I want clusters of 3 because I have a cubed root that I want to cancel. Here I have 4 negative 3's, and I only need 3. Here I have 4 2's, and I only need 3. And I have 2 2's here in this 4, so that's not going to cancel this cube root immediately anyway. So let's see what happens here. I'm going to carry this cube root of 4 along for the time being. And I'm going to break this cube root of minus 3 to the fourth up as minus 3 cubed times minus 3. So notice I had 4 minus 3's here, I have 4 here. So you have to make sure that you have the same number when you're trying to break this down. Similarly, I'm going to break this guy down into 2 to the third times 2. I have 4 2's here, I have 4 2's here, we're good to go. Use the product rule once more. And this is what we end up with. We end up with the cube root of minus 3 cubed times the cube root of minus 3 times the cube root of 2 cubed times the cube root of 2. As you can see, this is getting very complicated, but all we're doing is we're employing the same rules and hoping that we get something nice at the end of this. So you have to build up a little bit of intuition to figure out exactly how you want to proceed with all of these problems. So, okay, so now we have a cube root and a cube of this minus 3 here. The power on the power is odd. So in this case, we get to keep our negative here. We don't have to take absolute values of the thing in the inside, even though it's negative, because we have 3 and a third power. Similarly, I have a negative 3 here. So when we have an odd power or an odd root, the negative gets pulled out. Okay? So I'm noting a lot of things at the same time here so I can skip a step. So we have 2 to the third cube rooted. So this will just become 2. So let's see if we can break this down a little bit further. So we have cube root of 4, because I didn't do anything with that. Here I have a third root of something to the third power. So that leaves me with just negative 3. So I don't have to cancel out the negative. And now I have this cube root of negative 3. So that becomes times minus, I like to put this in parentheses, cube root of 3. The negative just got pulled out. That's all that happened here. Be careful that you include the parentheses so that it doesn't look like you're trying to subtract these two things. So continuing on, we have 2 cubes cube rooted, so that just gives us 2. And all I'm doing is handling this one step at a time. Cube root of 2. Combining what I can, I have a cube root of minus cube root of 3, and I have a cube root of 2 here, so we might have to combine those in the future. I have this, and these two things can be multiplied together. So I have cube root of 4 times minus 6 times minus cube root of 3. And then this is also going to be times the cube root of 2. All right, so another thing is we have minus times minus, so that becomes plus. Let's do that in the next step here. So we have 6 times the cube root of 3 times the cube root of 2. Okay. Cube root of 3, cube root of 2 can't be broken down. Cube root of 4 can be broken down into factor of 2. But since we just have cube roots being multiplied here, let's see if we can recombine them and then use a factor tree. So we're going to use the product rule in reverse. It's all the same radicals. We're just going to have them all under one roof now. So we have 6 times cube root of 4 times 3 times 2. Okay? You could combine this so that you get 24 and then use a factor tree. But we almost already factored here. All we need to do is break down this 4. 4 is 2 times 2, so this gives us 6 times the cube root of 2 times 2 times 3 times 2. All I did was break down the 4 and carried everything else along. So now I have 3 2's. That's exactly what I'm hoping for here. So this gives me 6 times the cube root of 2 cubed times 3. Using the product rule again, this gives us 6 times cube root of 2 cubed times cube root of 3. Cube root of 2 cubed is going to just be 2. The radical with the cube root cancels the power. So this gives us 6 times 2 times cube root of 3. Or if you like, this is going to be 12 times the cube root of 3. So this looks like a massive amount of work, and it is. But as soon as you start seeing the pattern, you can skip a lot of the steps that are happening here. I'm doing this just to illustrate every single thing that's going through my mind as I'm doing this problem here. So notice we yo-yoed back and forth between using the product rule to break things up, using the product rule to reabsorb things, so everything's under one radical, and then breaking it up again and reabsorbing. But again, as you work through these, you'll see the pattern, and it'll become easier and easier, and this actually won't require as much work to handle these sorts of expressions. So don't be intimidated by this. It does get easier as you get better at it. So with that, we are done with this expression.